Welcome to ClickMyProject.com. Let me discuss about the process autonomous self-optimization of coverage and capacity in LTE cellular networks. Let me discuss about the abstract of the project. Self-organizing networks provide service for saving the energy to operators when working under the modern cellular network infrastructure. Modern cellular network are long-term evaluation and LTE advanced system by improving the network deployment and network operation phase can save both capital expenditures and operational expenditures. Mobile data traffic is occurred among more number of users, which is overcome by optimizing the network coverage and network connectivity capacity. This above strategy optimized using self-organized networks in proposed work traffic light related approach, which is performing autonomous self-optimization. This above mentioned indicators are used in LTE multi-tier networks. In optimization operation, consider low complexity interference approximation model, which is formulated as a mixed integer linear program. This program is fed into the self-organized network for performing efficient optimization problem. Parameters of E node B's, HE node B's are the tuning site activity, transmission power, and antenna down tilt. When network changed, the optimization procedure is performed well with automatically adapted time variant optimization parameters. The radio resource status reports are separated in uplink and downlink reports, including the total allocation guaranteed and non-guaranteed bit rate traffic, the percentage of allocated physical resource block, and the percentage of PRBs available for load balancing. Financially, the simulations are performed and analyze the benefit potential of overall concept. Let me discuss about the flow diagram for our process. First, initially network has been formed. Here LTE node Bs are related to MCs and HE Bs are deployed in FCs. Then all transmitter are used same access technology at the same frequency. Each user in the system requires a certain data rate and is associated with a predefined priority level. While the data rate is directly related to the request service, the UE priority can correspond to either the service class or the user type. 16 channel quality indicators as described. Each CQI corresponds to a supported modulation scheme and code rate for downlink transmission. In the solvation of JOCOCA max joint coverage and capacity maximization algorithm, initially define the objective function which represented the KPI metrics that would be maximized by tuning the control parameters, that is the optimization variables, the maximization of covered priorities to maximize coverage and the maximization of the effective sum rate to maximize capacity, coverage of a DN and its priority value by an HENB requires the selection of the particular transmitter and configuration combination. The objective functions are reformulated. The minimum SANR condition for coverage by transmitter as a minimum link quality constraint. Next, the autonomous traffic light based system control are developed. Initially, all MTN cells are monitored the relevant network status informations and is act as input, which is to track system performance in terms of KPI metrics. Proposed MTN control and optimization scheme is available on single ENB level, on a cluster level, or on a full network level. Mark all cluster ENB as CCO candidates. If candidates are not located, then traffic light TL evaluation for CCO candidates and sorts according to their TL priority. If candidates are located, then JOCA max, that is joint coverage and capacity maximization algorithm for all cluster ENBs are performed. The evaluation of traffic light, that is worst ENBs, is in case 1. Then solve joint capacity and coverage maximization algorithm for all CCO candidates. The evaluation of traffic light is not in case 1. Then solve both or coverage maximization and or capacity maximization algorithm for worst ENBs. If improvement is there, the or coverage maximization process then apply solution for cluster ENBs and all HENBs. If improvement is not there in or coverage maximization process, then remove worst ENB from CCO candidates. If improvement is there in join coverage capacity maximization process, then apply solution for cluster ENBs and all HENBs. Finally, perform join capacity and coverage maximization for all cluster ENBs. End the cluster CCO. Finally, performance has been analyzed. Performance of uncoordinated SONM and coordinated SONM is analyzed by varying the resource allocation. Performance of the network is processed. Also, the channel availability arrival rate of the user is analyzed. Let we discuss about the running procedure for our process. Select the main.m file in the current folder, right click that file and run for executing this process. And here we obtain, this is the node deployment, that is users deployment, either node Bs and HENBs, and this is the capacity maximization graph by varying the iteration number, and this is the node deployment in the located area. This is the curve for both coverage indicator and also capacity indicator. This green and yellow line indicates the threshold value, and black and blue represents the coverage and also capacity indicator. Varies between 0s and 1s, and this is the optimized coverage and capacity indicator, and this is the normal capacity indicator, and here we using join coverage and capacity maximization algorithm. So with the optimization algorithm we obtain the coverage and capacity indicator like this way, and this is the coverage indicator. Utilization ratio we obtain 1. Capacity of full channel state information including all pilots is this. Now we perform the autonomous self optimization, that is join coverage and capacity maximization algorithm. We increase the coverage maximization as well as capacity maximization. Thank you.